Let's extract the switching threshold for a quadratic integrate and fire neural model done with a behavior voltage sources in LT-Spice. So we have the same setup as we had before, and it's probably best just to run the simulation to show you about extracting the switching threshold. So the switching threshold is the value at which if the output goes beyond, it continues spiking. But it's if it goes beyond a certain value when the input turns negative, because this is an integrator. If you're integrating a positive value, you're going to increase in area. If you're integrating a negative value, you will decrease in area, right? So it's this time sensitive thing where here we can see we just keep integrating because B is positive, and notice we stop integrating because B goes to -1 right at that point, right? It just starts integrating. But because the circuit is bistable, it's got that squared in it, right? There'll be a point where even when I go to -1, the circuit will continue to spike. And so that would be, the point of no return or the spiking threshold. So this is the important value that we're trying to, the switching threshold, which is -1. So when we look at the equation for the switching threshold, it's the square root of the absolute value of B when it goes negative. All right, so it goes to -1, the absolute value is 1, the square root of 1 is 1, switching threshold should be 1. Now we can calculate the rise time when we get to 1 and hone in on that. But since we've done 1, it's probably just easier to find the time when the output is 1. And that's about 8 milliseconds. So to measure this, I want to change the pulse width here till around that area. And I'm going to sweep it so that I can see what's going on. So we're going to step it, remove the decimal point, and we can go from 7.5 milliseconds to 8.5 milliseconds in steps of 0.01. All right, and we can rerun the simulation, and we can see it's stepping, still not spiking, not spiking. It's not. We're getting closer, almost. Slope is starting, and there we go. All right. So right in there is when we reach that point of no return. We always went down to -1, but at some point, even when we went below, it went off. Now we can zoom in on that data, all right, to get a better idea. And that's a lot of colors to figure out. But let's just zoom in on right where the slope goes from negative to positive, because that's the interesting point. So the green here is slightly positive, the black is slightly negative, and so the switching threshold will really be in between there. So I'm just going to put it halfway, and if you look at the, oops,